I'm going to be doing another similar example where we have a negative fraction and a positive fraction, and we add them together. But first, let's solve 3 plus negative 7. To solve this using green and red pom-poms, first I would get 3 green pom-poms because in this case, each green pom-pom represents positive 1. 1, 2, 3. Then I would get 7 red pom-poms because in this case, each red pom-pom represents negative 1. Negative 1, negative 2, negative 3, negative 4, negative 5, negative 6, negative 7. To figure out what 3 plus negative 7 is, I simply remember that negative 1 plus positive 1 is equal to 0. That means when I have 1 green pom-pom and 1 red pom-pom, I know that they would total up to 0, so I can remove them from the scene. And I continue doing so until I am left with 4 red pom-poms. Because each red pom-pom represents negative 1, 3 plus negative 7 is equal to negative 4. What is 3 ninths plus negative 7 ninths? Well, first, negative 7 ninths is equal to negative 7 ninths. Now, let's get 3 ninths. I'm going to be using this piece to represent positive 1 ninth. If I had 9 of these, it would complete a circle. In addition, it is green, which is similar to the pom-pom problems we had in which a green pom-pom represented positive 1. Let's get 3 of these. Now, let's get negative 7 ninths. I'm going to be using this piece to represent negative 1 ninth. If I got 9 of these, it would complete a circle. In addition, it is red, similar to the pom-pom problems we had in which a red pom-pom represented negative 1. Let's get 7 of these. So how would I solve 3 ninths plus negative 7 ninths? I can remember that positive 1 ninth plus negative 1 ninth would equal 0. That means if I get a green piece and a red piece, they will total up to 0, so I can just remove them from the scene. And I can continue doing so until I am left with 4 red bits. Because each red bit represents negative 1 ninth, that means that 3 ninths plus negative 7 ninths is equal to negative 4 ninths. Now, how can I remember that without using this model? Well, we can remember that negative 7 ninths is equal to negative 7 ninths, and that negative 4 ninths is equal to negative 4 ninths. You may have noticed in this problem, everything was very similar to the one where we solved 3 plus negative 7. We are using the same method, except everything was in ninths. That means that we're adding the numerators, but the denominators are all the same. If I wanted to use this example to show that subtracting fractions is similar to adding fractions, that is, that the numerators do the operation, but the denominators stay all the same, that is, that I would solve a problem like this: negative 4 ninths minus negative 7 ninths is equal to 3/9, I will simply do the opposite of what I did for the addition problem. Now let's talk about an example in which we're adding two negative fractions. Before we do that, however, let's solve -6 plus -3. First, I need to get -6. I'll be getting 6 red pom-poms because each red pom-pom in this case represents -1. -1, -2, -3, -4, -5, -6. Then I need to get -3. So I'll need to get 3 red pom-poms. -1, -2, -3. Please note that we have all red pom-poms. Nothing cancels out. So to figure out what -6 plus -3 is, we simply count the total. -1, -2, -3, -4, -5, -6, -7, -8, -9. So -6 plus -3 is equal to -9. So what is -6/10 plus -3/10? Well, first, -6/10 is equal to -6/10. And -3/10 is equal to -3/10. Now let's get -6/10. I'm going to be using this piece of a circle to represent -1/10. If I had 10 of these, it would complete a circle. Also, it is red, similar to the pom-pom examples in which the red pom-poms represent -1. Let's get 6 of these. Now, let's get -3/10. Please note that all we have is red. There is no red and green to cancel each other out. So we cannot cancel anything out. We cannot remove anything. So let's figure out the total by counting what we have. -1/10, -2/10, -3/10, -4/10, -5/10, -6/10, -7/10, -8/10, -9/10. So -6/10 plus -3/10 is equal to -9/10. So how could I figure that out without using this model? Well, first, let's change the -6/10 to -6/10. And let's change the -3/10 to -3/10. We can also know that -9/10 is equal to -9/10. This method of solving -6/10 plus -3/10 was a lot similar to the problem in which we solved with pom-poms, the problem of -6 plus -3 equaled -9. The only difference was everything was in tenths in this case. So this shows that the numerators are adding, but the denominator stays the same throughout. For this example, to show that subtracting fractions works in a similar manner to adding fractions, that is, that you do the operation with the numerators but have the denominators all the same, you would simply do the opposite of what we just did. There is an easier way to show that -6/10 plus -3/10 is equal to -9/10. We already know when you add two positive fractions together, it goes like so. The numerators add, the denominator stays the same. So we can figure out that 6/10 plus 3/10 is equal to 6 plus 3/10. Then we can take the negative of both sides. you can then figure out that negative parentheses 6/10 plus 3/10 is equal to negative 6 plus 3/10. And then we can use the distributive property to distribute the minus sign on the left side. In the description is a link of where I explain this aspect of the distributive property. And then we can get on the left side negative 6/10 plus negative 3/10. And on the right side, we already figured out that if you have the minus sign with the numerator or the minus sign to the left of the fraction, it doesn't matter. It is the same value. So I can then say negative parentheses 6 plus 3 and that over 10. And on the left side, we can then use that property again. The minus sign can be with the numerator or to the left of the fraction, and it is the same value. And we can get negative 6/10 plus negative 3/10. On the right side, we use the distributive property again and distribute the minus sign. And we get negative 6 plus negative 3 all over 10. And then to actually solve the problem, you can simplify that further, and you would get negative 6/10 plus negative 3/10 is equal to negative 9/10. So this shows that this idea of adding the numerators and having the denominator the same works also when the numerators are negative. The next video in this set of videos is about when you include negative denominators. If you wish, feel free to click on the link here below.